Hey, welcome to this video on comparing functions. We're going to talk here about a Chapter 3 skill, compare functions, and we're going to look a lot at linear equations. I'm starting off here in our toolkit. I want to make sure that your toolkit is up to date with all of your notes. You can see all of my notes here on the top, and you can go ahead and pause the video to record anything down that you need. Now I'm assuming you're coming back in, so I'm going to talk about a few things here before I scroll down and show you the rest of what you can write down. First off, I talked about the fact that a linear equation is a line. That's what I want to focus on, and I highlighted that right here. A linear equation is an equation that forms a line when graphed. You can remember that because linear starts with the word line. All right, it's not a line graph. A line graph technically connects points in lines, separate lines that all connect different points. It's a type of stats graph, but in this case, a linear graph is when the entire graph is one complete line from top to bottom, and all the points on the graph are points on that line. All right, and it has a constant rate of change going from left to right all the way. Now, another piece that I looked at, although standard form here is important, that's when x and y are on the same side, I focus a lot on slope-intercept form. That's this one right here. We call it slope-intercept form because it gives us two pieces of information, m, which is our slope. All right, that's the number in front of x. It's also known as the rate of change or the growth factor, and we call it our change in y, and that's what you can see down here, a change in y over a change in x. That little triangle symbol means change in. It's Greek symbol delta for change in, so change in y over change in x. We also have a nice little formula that we can use to calculate our slope if we have any 2 points. So change in y could be calculated by just doing y2 minus y1, and then the change in x could be calculated by taking x2 minus x1. So that's how to do it algebraically. We'll look at how to use it in table and everything here today. Let's look at the second piece of it. We said it was slope-intercept form because the b value is my y-intercept, also known as my starting point, the initial value in a word problem. The y value when x is 0, if you're talking about a tile pattern, is the number of tiles in figure 0. So that's why it's called slope-intercept form. It gives us those two pieces. And if I asked you, just giving you an equation, if I asked you to identify the slope and the y-intercept, you would just merely look for the number in front of x, that's my slope, and the number by itself, that's my y-intercept. Let's give you a few examples. What if I just said, let me change my color here for you. What if I just said the equation y equals 4x minus 5? Well, if I asked you for your slope, you'd say the slope, m, is 4. It's the number in front of x. It does not include x, just the number in front. If I asked you for your y-intercept, all right, we would say that b here is negative 5. So my y-intercept is technically, always starts with 0, comma, and then negative 5. All right, it's the y value, the y-intercept. The y-intercept is a point. What if I asked for the equation y equals negative 1/2 x? Well, you'd say my slope is negative 1/2. It's the number in front of x. What's my y-intercept? Well, I'd look here for the constant. In this case, I'm not adding anything, or in other words, I'm adding 0. So my y-intercept would be 0, comma 0. All right, what if I did something like this? Y equals 5. All right, well, now at this point, I'm looking for my slope. I'm looking for the number in front of x. Well, I don't see any number in front of x because it's technically y equals 0x plus 5. And so in this case, my slope is 0 because there's 0 x's. My y-intercept, however, would be 0, comma 5 because that's my constant. This number right here is the number without a variable, and it is my constant. To give you a unique example, we'd also see something like this. X equals 2. Is that in slope-intercept form? No, it doesn't start with y equals. It's not in slope-intercept form because this doesn't have a slope. We would say the slope here is null or undefined. All right, so it's either null or undefined. All right, so you can kind of see those pieces from the equation itself. There's also no y-intercept here because it's also not in slope-intercept form. So this is a unique case. When comparing functions, they typically won't work with one of those or give those to you, but one should be prepared just in case. But now, let's take a look at a graph. A table. If we take a look at our examples of tables over here at the right, the ones you copied down, you had 2 examples. Example number 1, and it shows we've got some decimals. I have an x value of 0. And in order to compare our functions, we want to be able to calculate the slope here. Our slope, again, is our change in y over our change in x. To find that change in y, you can pick any 2 points from your table. It doesn't matter. I picked 0 and 3 because they were whole numbers. That made it easy for me. So I ask myself, how am I moving from 0 to 3? Well, I am adding 3. That's why positive 3 is my change in y, and that goes on top for my slope because my change in y is on top. Then I go to my change in x. I have to pick the same 2 points, and I have to go in the exact same order as well. So in this case, I'm going from 1 to 3, and in that case, I'm adding 2. That's my change in x. That's why it was on the bottom. My change in x is on the bottom there. So I found my slope to be positive 3 over positive 2, and if I simplify that, I get 3 over 2, and that goes in front of x for my equation, if I'm looking to write my equation there. But what about my y-intercept? Well, my y-intercept is always the value when x is 0. So I'm looking at this part of the table to find where x is 0, and here it is. What's the y value when x is 0? Negative 1.5. So negative 1.5 is what I put at the end of my equation. That's my y-intercept. If I were to write out the y-intercept, it'd be 0, negative 1.5. All right, so that's example number 1. Take a look at example number 2. Again, my slope, pick any 2 points you want. I just went from 5 to negative 1, the first point there. 5 to negative 1 went down 6. That's my change in y, and that's why that is on top of my equation. Sorry, my fraction, because my change in y is on top. Next, I pick the same 2 points, going from 2 to 4, and I notice I'm adding 2, and that's my change in x, which is why it goes on the bottom. And if we were to simplify negative 6 over positive 2, we get negative 3. All right, so that's my slope, and that's why negative 3 is what went in front of x in my equation. My y-intercept, I'm looking for where x is 0, but I don't see it in this table. So I've got to work backwards. I notice that I'm going up by 2 every single time here. So if I just go back by 2, I'll get to 0, which is nice. Well, if I'm going up by 2 on the x values and I'm going down by 6 on the y values, if I go back 2, well, then I've got to go back, in a sense, on the y values. So I'm going to be going up 6. I'm doing the opposite to get back there so that I can see I'm consistent in my table the whole way. So if I start with 11 at x equals 0, I am still jumping at a constant rate the whole way because lines have to jump at a constant rate. Either way, I'm able to work back and find out that the b value here is 11, and that's what goes into my equation. Again, if I were to write my y-intercept out, it would be 0, 11. All right, so that's tables, that's equations. Let's take a look at graphs now. Scroll on down here, and we're going to see what graphs look like. Take a moment. If you don't have this here, you can pause the video and copy everything down. If you do need a graph grid like this, you can draw your own little graph grid carefully there. Or if you do want to cut one out, I've got plenty in the classroom that you can cut out, and then you can staple it or tape it in there. All right, now coming back in, you've copied things down. Hopefully your toolkit's all set. I'm going to look at a few things. First, my red line. And in order to read my slope of my red line, I have this down here. You always read from left to right. You can pick any 2 points you want. It does not matter. But you must go from left to right. All right? So I can pick any points I want. If I go at this point right here, my y-intercept from 4, and I pick the next point, I'm not picking any of these 2 points in between because they're not whole numbers. I like to pick numbers where I can clearly read the coordinates. So this one would be 3, 6. All right, this point right here is 0, 4. So I like them where I can read those coordinates. So if I'm moving from my left point to my right point, I first start by going up or down. In this case, I'm going up 2. All right, and I mark that there with a little +2. And I'm going over, always over from left to right, I'm going over 3. Therefore, my slope is read as up 2 over 3 because up is always read as a positive number. All right, and then I'm always going over from left to right, and so the word over reminds me that it's over top of 3 in the fraction, and it's also going over from left to right. Notice it's continuous as I keep doing that, up 2 over 3, up 2 over 3. If you picked any other points on that line, it would still work. What if I picked this point here and this point here? Well, now I'm going up 4 and over 6. So a slope of up 4 over 6 reduces to 2/3. Still the same exact thing. So it gives me my slope. And that's what you see over here as I read it, up 2 over 3. And that's why my slope, 2/3, is put right in front of x there. The y-intercept is much easier to identify. You're merely looking for where the line crosses the y-axis. Please remember it's called the y-intercept because it's where it hits the y-axis. In this case, it is 0, 4. It's a little bit light green there. If you can't see that, I apologize, but a little bit light green. But 0, 4, that's why b is 4, and so therefore we put 4 at the end of our equation. Notice it is a +4 because it was a +4. As you'll see in the next one, if it's a negative value, then you just put minus. All right, take a look at the next example. Again, I'm going to pick any 2 points. I pick points that are nice grid line points. This one here I can see is clearly -5, -1. I can read the coordinates of that point. That's why I chose it. This one here, the y-intercept's always one of my favorite ones to choose, and that one is 0, -4. So if I go from the left point to the right point, I'm going down 3 over 5. That means my slope is going to be written as down 3 over 5, or -3/5. And that's what we see here. Down 3 over 5 becomes -3/5, which is what I then put in front of my x. My y-intercept, as we saw here, all right, is 0, -4. And since it is -4, I just put -4 at the end of my rule. So that's reading our graph. Again, we want to be able to identify our slope and our y-intercept from any situation that they give us. They'll give us a table, they'll give us an equation, they'll give us a graph. Sometimes they'll give you a situation, sometimes they'll give you 2 points. And let's take a look at a few of those examples now as we do some study island examples for you. So here in example number 1, they're going to ask us to compare and describe the rates of the following items. I'm going to do more than just the rates. I'm going to always compare the 2 items that we typically look at, and that is our rate, also known as our slope, and we're going to also look at the y-intercept. Because you never know what question you're going to get. Here, if they just ask for slope, that's fine, but I want to look at it in a little bit more detail. So let's look at the equation first. The slope is the value in front of x. In this case, m equals 3, and therefore it's positive, so it is increasing. All right, let's look at the slope of our graph. Slope of our graph, pick any 2 points you want. Oh, we got a nice x-intercept here and a y-intercept there that I can pick. I'm going up 2 over 2. So up 2 over 2. So m is up 2 over 2. 2 over 2 reduces down to 1. If you saw some of the smaller ones, you could have gone up 1 over 1, up 1 over 1, up 1 over 1. All right, so again, it doesn't matter what 2 points you pick, it will reduce to the same slope. It is also positive, and therefore it is increasing. So if I just look to compare this without any direction from them, I would notice that both are increasing. All right, so they're increasing here, both positive slopes. And I do notice that the equation is increasing at a greater rate because 3 is greater than 1. That's my slope or growth rate over there. So I see that the equation is increasing at a greater rate of change. Let's take a look at their y-intercept now. For my y-intercept, I just want to identify the constant in the equation, the number without the variable. All right, this one right here. And the reason that works is because for my y-intercept, the value of x will be 0. Remember, it's always 0, comma, a number. And so if I plug 0 in for x, all right, well, what's going to happen to 3 times 0? Well, the whole thing becomes 0, and therefore the entire thing pretty much disappears, and I'm left with just the constant, 2. That's why the constant is always my y-intercept. All right, so 0, 2 is my y-intercept in my equation. If I look on my graph, where does it cross my y-axis? Well, it crosses there at 0, 2. Which one has a greater y-intercept? Well, they're both the same. They have the exact same y-intercept in this case. Let's take a look at another example. In example number 2 here, they give us a situation, a line with a y-intercept of 0, 3, which passes through the point 2, 7. We'll talk about that one. It's a little bit trickier. And they give us a table. All right, and they want us to compare and describe the rates of change. Once again, I'm going to compare not just the rate, also known as the slope. I like to call it both because I typically refer to it as slope more, but you need to know both names, and the y-intercept. All right, so let's look at both here. First off, my first equation, it starts off y equals something times x, but they told us the y-intercept was 3, so I know it's going to be a plus 3. Now, what's it increasing? It's a little bit of a challenge here with the 2 points. You could get out a graph and plot them both, and then you could follow the grid lines to find out how much up and over. I'm going to use the formula that we talked about on our formula page that was y2 minus y1 over x2 minus x1. What do y2 and x2 and y1 and x1 represent? Well, it just means our points, and it doesn't matter which one's which. I like to say the first point here is my y1, x1, and the second point here is my y2, x2. So my slope is going to be y2, which is 7, minus y1, which is 3. Make sure you take the y values. That's the second number in our piece there, so 7 and 3. And then x2, which was 2, minus x1, which was 0. 7 minus 3 is 4, 2 minus 0 is 2, and 4 divided by 2 is 2. So my slope here is 2. It is positive, it is increasing, and we're going through a y-axis at 3. Let's take a look at my table to find those same pieces there. Pick any 2 points you want. I'm going to go from -4 to -3. I'm going up 1. And from 0 to 3, I'm going up 3. So my slope, change in y over change in x, is up 1 over 3. In other words, 1/3. All right, so it is increasing. Which one's increasing at a faster rate? Well, my equation over here, or sorry, the situation they gave us in function 1 is increasing faster because 2 is greater than 1/3. All right, but let's look at my y-intercept. Well, that's when x is 0. So I see I've got a value of -4. So b is -4 in this case. And I see that in this case, my y-intercept of 3 is greater than my y-intercept of -4. It's higher up on the y-axis there. The equation for the second one here, just to practice, is going to be 1/3 x minus 4, because always our slope or our rate of change goes in front of x and our y-intercept tailed on at the end. Let's take a look at another. As we take a look at this one here, now we're comparing a graph and a table. And it says compare the y-intercepts, but once again, I'm going to compare the rate or slope, and I'm going to compare my y-intercept. All right, so starting off with my graph, I'm going to pick any 2 points. I like the y-intercept as a point, and I'm going to follow it along. I see there's another good point right there. I see that's 1, 1. Again, I like picking points that have whole number coordinates. To give out a few others, there's that one there and that one there. But going from my left point to my right point, I'm going down 3 over 1. Down 3 over 1. So that gives me a slope of down 3 over 1. In other words, -3. It also crosses through my y-axis at 4, so I'd have y equals -3x plus 4. All right, so I see it's decreasing. All right, this is a decreasing situation. And it's decreasing at a rate of 3 over 1, and it started at 4 on the y-axis. Let's take a look at my table. My change in y, picking any 2 points, my change in y here is going to be going down 1 from 2 to 1, and my change in x is going to be going up 1. That gives me a slope of down 1 over 1, or in other words, -1. And my y-intercept is where x is 0, so that's right here. It's going to be a value of 2. So my equation would be -1x, or just -x, plus 2. I notice this is also decreasing, so both slopes are decreasing here. Which one's decreasing at a faster rate? Well, -3 is a faster rate than -1. Because again, I know that the number -1 is technically bigger than the number -3, but we're looking at just the numeric value without the sign. So 3 is greater than 1 here. That's why this one's decreasing faster. The slope of the line is steeper. All right, and so if you put a sled or a ball on it, it would go at a faster rate. Look at my y-intercepts. Which one has a greater y-intercept? Well, 4 has a greater y-intercept. So function A here is really winning out overall. All right, it's decreasing at a faster rate, and it has a greater y-intercept than function B. I hope that helps for some examples as you're going through this. If you need more, come see me, and I can help you out.